Welcome back to DellyMaths Concepts. Today we are looking at one of those speed versus time graph. One of those CXC questions that comes at number 9. So it says the diagram below shows the speed time graph of the motion of an athlete during a race. And so we're looking at that. Okay. So this idea that we have here is really representing the motion of an athlete, as you could see the various phases, right? All right, good. Now let us see the questions that we're being asked to handle. Uh, Using the graph, determine number one, the maximum speed. All right, so we're asked to determine the maximum speed. So let us take a look at the graph. So the maximum speed, as you could see, the speed is on this axis. And so we're looking for the highest point for this graph. And so the highest point for this graph, you could look, you'll definitely see it, that the highest point for this graph is right here. So this is actually 12. The highest point for a graph is at 12 right there. So we could respond to that easily. It's 12 meters per second. So let's deal with that. So the maximum speed was equal to 12 meters per second. All right. So that one, we never had to do any working really. All right. Now, let's take a look at the second question here. It says, we want to determine the of seconds for which the speed was constant. So if the speed was constant, it means that it's not increasing. So let me show you where the speed is not constant. Here, the car or the speed of the person is accelerating until it reaches that maximum speed. So when it reaches this maximum speed right here, you notice that the speed remains the same at 12. So it was constant from 6 seconds to 10 seconds. So between that, right? So if you should say, okay, 10 minus 6, it's going to tell us that it's 4 seconds of the journey that this car was, that this athlete was at a constant speed at, right? So the number of seconds for which the speed was constant, we did just work it out and we're getting 4 seconds. So for 4 seconds of the journey, the speed was constant. Now let's take a look at the C question. It says the total distance covered by the athlete during the race. Now, the total distance covered is an idea that we can calculate by looking at the shape that we got. The shape that we got was actually a trapezoid. And if I'm able to find the area covered under this trapezoid, then I'm definitely dealing with the distance that was traveled. So the basic idea here is that the distance traveled can be found. We can find this by taking the area of this trapezoid. So the area of this trapezoid would give a very good idea of what it is. So let us find that. How do you find the area of a trapezoid? The area is equal to, I'm going to just put some symbols here, half A plus B times H. Now, what am I referring to? A plus B refers to the parallel sides, the sum of the parallel sides. So one of the parallel sides here was 4. That would have been the distance here. We found out that that was 4. And then the other parallels, the other sides as parallel is 13. So right down here, this is 13. You could see this distance here. So what we're going to do is to say half 4 plus 13. And then we're going to multiply that by the height. And the height would have been from 0 to the maximum speed there. That would have been times 12 right here. So we could work it out whichever way. 2 into itself 1, 2 into 12, that's 6. Inside the bracket, we're going to have 17. That's 13 plus 4, 17. And we multiply this by 6. So we're actually getting 17 times 6. That's 102 meters, all right? So let's drop that in. What we got here for the total distance covered, it's going to be 102. The unit was meters. All right, so it's 102 meters that was covered. All right, let's take a look at the other question here. So in part 2, it says during which time period of the race was A, the speed of the athlete increasing? Let us take a look. We want to know when the speed of the athlete was actually increasing. So we could look. The speed of the athlete was increasing from here until we reach right here. So what we want to do is to take a look at the time that it occurred. So it's between 0 to 6. So between 0 to 6 seconds, you could see that the athlete speed was climbing because you could see 2, 4, 6, 8, 10 until it reaches 12 to 0 to 6 seconds. So between 0 to 6 seconds, that was when the athlete was increasing, right, in speed. Now, the B part says the speed of the athlete decreasing. So decreasing is when you're seeing that the speed is getting slower. So if we double check this quickly, we're going to notice that when we have this is when it's going down, because it's going down to smaller numbers, as you could see, and so on until it reaches 0 here. So the time that we're dealing with, though, the time frame that we're dealing with would have been from here coming to here, and you could see it's from 10 to 13. Right here was when the speed was actually reducing. So between 10 to 13 seconds. So we could drop that in right here. So it was between 10 to 13 seconds of the journey that the speed decreased. Now, we also want to look at when it is that the acceleration was 0. When the acceleration is 0, the speed would have remained constant, because the moment you're accelerating, you're changing your speed. And the speed was not changed during this time period here, right? So the speed remained the same from right here to right here. The speed was the same here. So it's 6 to 10, right? So the time interval where the acceleration was 0 would have been from 6 to 10 seconds of the journey. All right. Now, thank you for watching DellyMaths Concepts. Stay tuned as we look on more videos. Bye-bye.